surprise, just know that to everyone's surprise, just know that this time the leaderboard will surprise you. I mean, it'll surprise you in which way that you'll have to figure out, because the numbers that we are seeing right now on this leaderboard is this. I hope everybody can see my screen. I would request my team to confirm if they can see the screen.
Yes, Deepak, we can see the screen.
Yeah, thank you, sir. Welcome to the session, sir. So yeah, we have only 3 names this time. The people who have touched the benchmark of 15. I don't know. It looks exciting as well, a little bit challenging as well, because I understand and know that a lot of students have scored 14, so you just missed the leaderboard by 1 mark. But kudos to everybody who could not be on this leaderboard, but keep trying. I mean, that's what this entire exercise means. That said, congratulations to Ritika Singh. You are on top by scoring 18 out of 20. Kudos to Ram Ganesh Lankada for scoring 15 out of 20, and Sri Pujitha Thamma for scoring 15 out of 20. Guys, you are doing a brilliant job. The people who are on the leaderboard and people who could not make the leaderboard, I know I can see the effort. Deepak Chaudhary, who reviews the quiz scores, sees the effort that you guys are putting in. Everybody is highly appreciative of what you guys have been able to achieve in the past couple of weeks. So keep up the hard work, and everything else will follow. Okay, so before we begin the session, I see Praveen sir is here. First of all, Praveen sir, thank you for taking all the time. If there's anything you would like to add before we begin the session, sir.
Yeah, thank you, Deepak, and good evening, all. I am Praveen Thakur, Chief Operating Officer for IBC Media, and I know I have been talking to all of you. And yeah, so I think the score that I see today, definitely, I would like to see more people crossing 15, and I would request all of you, and I would also request my team to analyze and see if there are areas in which you need help. We should do that. So Deepak, if you don't mind, I'll take a few minutes to kind of talk about a little bit about the context, what the team is going through right now.
Absolutely, sir. Please.
Yeah. So look, let me start like this. So I know that we have Selva sir, we have Deepak Chaudhary, who are trying to help you with Rust. I want to take a step back and kind of explain to you why what you are learning is important. Okay. If Deepak, if you can allow me to switch on my video, please.
Yes, sir. Let me just stop this. Is it? You mean the video or the screen share? Let me stop the screen share.
No, video.
Okay. Deepak, Goodem, I think we'll check the access.
Still cannot do that. Deepak Goodem, are you working on this? Okay, so while that happens, yeah, so while that happens, guys, you guys are right now working on trying to learn Rust, and Rust is a very fundamental language, and it is going to be very, very promising language in blockchain technology. And of course, our headline sponsor being Polkadot, which leverages Rust, and you will be able to build a lot of things with Rust language. Now, having said that, there are few other things that you also should understand. What's really going on in blockchain. So blockchain, as you know, blockchain has got a feature called smart contract. Smart contracts are basically auto executable code, which when deployed onto the blockchain, then these smart contracts have functionalities which can meet various business functions. Now, these various business functions could be coming from finance, which we call DeFi. They can come from metaverse, related businesses such as games. Then you have, other businesses such as, insurance. Then you have got agriculture. You have got supply chain. There are several business areas in which these smart contracts are made use of. Okay. Now, so typically what happens when you deploy a smart contract, you need to have an environment in which these smart contracts are run. Okay. Now, typically that could be any environment. Now, conventionally, if you look at Ethereum, for example, they have something called Ethereum Virtual Machine, EVM, in which you go and execute your code, right? So when you deploy your smart contracts, then it gets deployed in that, and then you can interact with those smart contracts by calling those functions or methods which are part of those smart contracts, right? Now, having so there are two types of smart contracts if you really see in today's context, right? One type of a smart contract is basically a virtual machine based runtime engine in which these smart contracts are deployed, okay, and they are executed. Now, they have got their own constraints, such as typically they are slow, typically there are limitations with which what you could do. Interoperability is a different challenge. They have got their own specific language, which you have to learn to do that, right? There is a second type of environment, runtime environment, which is basically where you have which is basically WebAssembly, WASM based smart contracts. Okay, so these are basically an kind of environment in which right now, if you look at programming language C++, and Rust. Now, these programming languages, if you write code in these programming languages, they can be compiled to this runtime environment. Okay. Now, when you do that, so what happens? Basically, it really has several benefits, right? One of the benefits is basically that you don't need to learn a new language. For example, Solidity and Viper. There are many other languages, right? And you could continue getting your continue working on your own preferred language, and you could ultimately, at the end of the day, you compile your program into WebAssembly, and then it kind of serves the same purpose, right? Now, there are so many advantages that really come out of this. So in my opinion, and whatever research and study that I have done, basically it really gives everybody an opportunity to leverage what is going on in this industry right now, which is the latest. Now, if you really ask me, one of the things that you should also kind of consider that in future, in my opinion, and as per most of the experts in the industry, the world is moving towards a mechanism in which what happens that all these generic approaches will matter more, right? A lot of, so if you really ask me what is WebAssembly, WebAssembly is basically a runtime environment which was basically created to run in the web browsers. Okay. Now, but then if you really look at WebAssembly, this has got its application much beyond the web browser, and when you do something, when you compile something into WebAssembly, then what happens basically is that it gets to a binary, and execution becomes very fast, and there are a lot of other benefits, right? So even if you look at all the the latest blockchains which are kind of using this WebAssembly, Polkadot, Polkadot is one of the most important blockchains today. You have got Near protocol, you have got Solana, In fact, Cosmos also have got they have got something called Cosmo WASM, right? So there, the code is compiled into the WASM format. And in my opinion, in future, these kind of there will be so many blockchains which will come, which will be using this WebAssembly. So in my opinion, WebAssembly is going to be transforming the way the whole, in fact, the web browsers kind of operate, number one. And the second thing is that they will be very crucial for blockchains as well. So to summarize my point, what you are learning right now, do not consider this is just a Rust class. What you are building right now, this is going to be fundamental to your blockchain or your development journey. Okay, and that is where it is very important to make sure that you take full advantage and don't rely upon whatever we teach you here. Go and do a lot of work. And I am particularly impressed by the three names that I saw today. And I do acknowledge Deepak Singh. Can you please put the name on again? Ritika Singh, I have been seeing you. I have been looking at your performance from session 1. I do want to congratulate you. And I do understand that you have been putting a lot of effort in the backend, in the background, to make this happen. This doesn't happen just like that. So many congratulations, Ritika. And I would request you to continue this passion, because blockchain needs people who know the subject. And Deepak Singh and I, we were talking earlier this morning, and we will be giving you some tips apart from what Selva sir is teaching you every day, something with respect to blockchain, which will kind of widen your appreciation of the whole blockchain field. I want to congratulate Ram Ganesh Lankada. Fantastic job, Ram. I think I have seen your name before also, and it is too heartening to see you guys performing. Sri Pujita Thamma, I have seen your name also. So you guys are cracking it. Please continue, go deeper, and become somebody who is needed in the industry. And I can tell you, Rust is not one blockchain. What you are doing right now is going to open up the whole blockchain field for you. So you are not realizing right now, what are you adding to your profile? You are just doing awesome. So continue this, go deeper into the subject, and we will help you appreciate the connection of this language with blockchain, as we go on. Okay, you can always follow IBC Media. You can always follow me on Twitter at the rate PK Thakur 11. I am active on PK Thakur 11, so you can follow me on Twitter. You can follow me on LinkedIn. But then the whole intention I have right now here is to make sure that you achieve what we are trying to aim for. Okay, with all these things, Deepak Singh, I am good. We can start the session.
Thank you so much for such a wonderful summary. And like Praveen sir has said, let's rock and roll. And everything that you're learning here is extremely important to your development career, because the Web 2 is pretty much now going to be obsolete very soon. So focus and try to learn and grab as much as possible. Salva sir, over to you. The real sessions begins now, and we will be hearing from IBC leadership like Praveen sir himself, and more in the coming sessions as well. Because, for example, today we spoke about the importance of Rust, and similar topics will be covering in our coming sessions as well. Salva sir, over to you. Thank you once again, everyone. It's good to have you all. Let's begin the session now.
Thank you, Deepak. And good evening, ladies and gentlemen. Okay, so one thing I wanted to add is that, because as you are learning, more and more advanced concepts, the quizzes will obviously, get a little more difficult with every step. Okay, so you have to keep that in mind. And as I've been telling you, it's important that you do your homework. Just read through the test book. That alone is sufficient enough to get you started to a very good extent. So it's imperative that you do that homework. Okay, I know that it's not easy attending the classes in the college and then coming back and then spending time with us and then doing something. But then again, this is the age and this is the time where you have to work hard in order to achieve your dream, right? So with that said, let us start our session today. Let me share my screen. So probably I think, Praveen sir, is it okay to discuss a little bit because of the previous quiz?
Yeah, sure. Please do that. I think, yeah,
That
that will be
if you
helpful.
put things
Yeah.
in context, okay, because you need to know where exactly you're making mistakes and what is going on in there. So Deepak Chaudhary, can you?
Yeah, so, Silva sir, I think
Yeah.
I'm absolutely fine. If
Mm.
this needs more time, so let us
Mm.
discuss on that. And if
Mm.
required, we can have a compensatory session some other time. If this session takes, because I want people to appreciate it, I will encourage people to ask questions to Silva sir here, so that whatever you could not get, because if only 3 people have crossed 15, I have concern. So I want everybody to please feel free and make use of this. And whatever time it takes, Silva sir will give you today.
Yeah, so that we can have some competitive session to clear, because I want that, you know, this is where we should, I think probably they need our support to understand where to refer to the material, how to do better and stuff like that. Okay, how you experiment, and so that way their understanding will become better and their scores will improve.
Yeah, and also I would also like, if possible, so you could refer to the question and see where people have done, most of the people have done mistakes, and maybe follow through that also.
Yeah, sure. So Deepak Chaudhary, can you just share your screen and put up the questions, and then we'll have a discussion.
Yeah. 1 second.
And give it just a moment. I'll just have a glass of water and come back.
Okay, guys, let's discuss through the third question. In this x.clone. 1 second, let me see. Yeah. Many of you have chosen the all of the above, fourth option, but the correct option is deeply copy heap data without cloning ownership. We use the clone method to not to transfer the ownership. Okay. Many of you have chosen clone ownership. That is not correct. If you want, you can see this. So what we are doing here is we just copy heap data. We are not cloning the ownership. Okay. This correct answer. Okay. Now next question. Yeah. Hello, Silva, so you have shared your screen. Hello, am I audible?
Yes, Deepak, we can hear you. So you can share your screen, or maybe Deepak Singh, can you please check with Silva?
Oh, sorry, I was on mute. Happens all the time in an online meeting. Okay. Okay, so let's look at this. So again, remember the concept is pretty simple. It has to get us, because ownership and borrowing is something that you have to understand are the core working mechanism, right? So essentially, again, if you do something like this, okay, let's say I have I'll just increase the font size a bit. Okay, so let's say if you have, let us one a sign. Okay, so what happens is that you have, again, it's stack and heap. I'm not going into the inner details of the string. So our actual string hello is here, and this is our pointer s1. And what it is doing is that it is pointing to the string. Okay. Of course, yes. So what basically will happen is it's got three parts to your string. That is, one is the pointer, the other is the length, and the capacity. So forget about it. So the simple thing is like this. Okay. Now what I do is, if I say let s2 is assigned s1. So see what happens. So you have an s2, but then again, what is happening here is that now the pointer s2, okay, is pointing to s1, and s1 is basically invalidated. Okay, so it's not pointing to anything, right? So let's just invalidate it just by putting up this point. I'll just put something on the other side. Now it has become invalid, right? This, so what is it? What is the mechanism going on in here? So basically, when you are doing it like this, okay. So what's happening is here the ownership is changing, right? Okay. Here ownership changes. So when you take a reference variable, there's a complex and you assign it to another one, automatically the ownership changes to S1. So the pointer now S1 is now taking up ownership and it's pointing to this, and sorry, S2 is pointing to this, and your S1 is now invalidated, right? So this is what is actually happening in here. Okay, so this is ownership change. But suppose I do not want to do it like this, then the other mechanism the other mechanism is wherein you say, okay, here what you do is you say S1 dot clone. Okay. In this case, what will happen is that you will end up with hello here. Okay, and S1 okay. So here what is happening? A new instance, okay, with deep copy is created. Okay, so what happens when you are cloning? So of course, yes, this also needs to why this is also valid. So what is happening? Basically, you have taken a deep copy. So in Rust, what happens when you say a deep copy? Okay, essentially it will do a deep copy. It will get the data, create a new object altogether. Okay, and copy the remaining things like the capacity and the length. Okay, so now S2 is not having ownership of the original S1 object, but a new altogether different object is created, and that is what is actually having so S2 will have ownership of that object. This is deep copy. You are copying here. What is happening? Whatever pointer was there, we just copied it into this place. Only the address got copied. So this is a shallow copy, whereas this is a deep copy. But this is a deep copy, that's true. But at the same time, okay, when you say deep copy and the ownership is not copied. Ownership, when you copy again, it will S2, even though new object is created, S2 will still point to the old string. Okay, that's not what is happening. The new string that is copied, okay, S2 is having ownership of that. Okay, can you explain the 9th one? Yeah, we will go ahead. We'll go ahead. Right? Okay. So, Deepak Chaudhary, we can go ahead, please.
Yeah, sure.
X dot clone. What was that?
X dot clone.
Yeah, okay, I did this. Yeah, right. This is what we discussed right now. Okay. which is false about enums.
So are you want to discuss this question?
What access is provided to the variable? FN report.
This is
Yeah.
pretty straightforward.
You see, whenever you see a reference in there, reference, it means you are doing a borrow, right? You are doing a borrow. So that means the original item is accessible through X, but when you do a borrow, you don't have ownership, so you can't change the value, you can't mutate it. Okay, so you only have read-only access. Okay.
Yes, sir. You can
Yeah.
describe.
So what are these? Cannot be destructured. Okay. Destructuring simply means getting the. So if you have some sort of a collection, okay, destructuring refers to getting all the data, right? But the traits don't have data. Tuples have, enums have, okay? Enum variants have values associated with them, right? Struct, obviously they have. So destructure you can only do when you have some data associated with it. Traits don't have data. Their traits are basically something that only has method definition, method declaration, right? Which finally has to be implemented through the IMPL block. Of course, traits can always have default behavior, so you can definitely do that as well. Okay? But still, they are a collection of methods which can be shared across multiple types. That's what traits are. So they're not any data. So you can't destructure a trait out there. Okay?
Yes, 7th and 8th, most of them are correct. But
9.
yeah.
Okay. So this is a little tricky. Okay, it's a little tricky. See, the whole point is you have to understand strings. I've been, constantly telling you that strings have to be, you have to treat strings differently, and you need to understand the strings. You have to read upon on the strings as well. Okay. So one of the things in Rust. Okay, so let me just show you here. So Deepak, you can stop sharing and I'll share. Okay. Okay, so let me go to the and look at what is a string. Okay. So if you see here, strings are all UTF-8 encoded strings. Okay. The string type provided by Rust standard library. Okay, rather than coded into a core language, okay, which is growable, mutable on UTF encoded string type. When Rust refers to strings in Rust, they might be referring to either a string type or a string slice. So that's just fine. Okay. So what you have to understand is that the Rust standard library, both string and string classes are UTF-8 encoded strings. And this is exactly what you really need to understand, okay, when it comes to the strings. Okay, so let me just show you. So first off, understand what is UTF-8. Okay, so there is a nice Wikipedia page. Okay, see, UTF-8 is a variable length character encoding. So if you all know this, you have ASCII code, right? ASCII code is fixed. It is a 7-bit integer, okay, value, and we use 8 bits, of course, but of which the actual ASCII code is only the last 7 bits in there. Okay, so what you have to understand is that it's not sufficient for ASCII to encode other languages. It's just wide enough to represent English alphabets and both uppercase and lowercase and special characters, stuff like that. Cannot go beyond that. So what do we do? So that's why Unicode was brought in. Okay. So Unicode is nothing but universal coded character set transformation. So UTF is basically a part of the Unicode transformation format. Okay. Now, see what happens is that suppose so for ASCII, with ASCII you can only encode these many characters. Okay, but if you want to support international languages, okay, then you would need a character set which is large enough to hold those many characters. Like for instance, if I want to bring in characters from say English, then Hindi, and then Tamil, and then Telugu, okay, not to mention pictographic languages like Chinese, Japanese, okay, right, and so on and so forth. When you want to bring all those things, then in that case you will need larger number of bits to encode these characters, right? But then what happens is if your entire application uses only English language. So generally with Unicode, what happens is that with Unicode we are actually, you can also see the Unicode standard. Okay, this is a Unicode standard. Okay, universal coded. So you have UCS ISO EC 10646. Okay. Now remember this Unicode characters. If you use fixed byte length, okay, fixed length, then what will happen? So let's assume that we are having 4 bytes. 4 bytes means 32 bits. 32 bits, you will be easily able to encode almost 1 billion characters. That should be fine enough. Okay. But when you do that, what happens is even a simple English string, okay, like even the character A, okay, which only requires 1 ASCII code, that's it. Okay, you are still using 4 bytes instead of just 1 byte that is sufficient enough. So there's a lot of wastage of memory happening. So that's why this UTF was brought in. So which is actually a variable length character encoding. Okay, so how do you encode the character? So this is how it looks like. So UTF-8 will encodes code points into 4 bytes. Okay, 1 to 4, depending on the value in the code point. So this is the code point. Okay. So if you are seeing that the first byte starts with a 0, okay, then you have 120 code points, and you will not use byte 2, 3, and 4. So everything is encoded here itself. So which would mean the remaining 7 bits that you see here, I can easily encode the ASCII letters belonging to most of the Cyrillic and the Latin characters. Okay. And if you want more bytes to represent, then in that case, what we do is the first byte will have 110, first byte, and then second byte will start with 10, and remaining X's. So how many bits are here? So there are 5 bits in here, and a total of 6 bits in here. Using this 5 plus 6, so you can have as many as 1920 code points. So similarly, you have, so basically what happens, every Unicode character that you see here, it can be 1 byte long, it may be 2 bytes long, it may be 3 bytes long, or it may be 4 bytes long, depending upon the requirement. Okay. So this is how the UTF actually works, right? So if you want to work with the Rust strings, so let me just show you. And you want to create a string, you can do it like this. Here it is. Okay. Of course, you can how to type this namaste here or hello here and all other characters in here. Okay, you can do that. You can definitely do that. Okay, so you have to look for how to type Hindi characters in, let's say, VS Code. Okay. So if you can't, then start typing display and you'll get configure display language. You can do that. Okay. Or what I can do is you can also do it using the what to say the actual Unicode character system. Okay. So one is you can, let's say, I'll just show you one little example in there. Okay. So either you type it directly or you can also give Unicode thing. So these are ASCII escape character, byte escape, and \u, and then in the curly braces you can give the actual Unicode. Of course, this is not typing. This is basically entering a character. So let me just show you here. So I can give and then Indian currency symbol is okay. Now, if you know that, you could actually \u, and then I can do 20B9. And let's run this. Okay, the rupee symbol is coming up. So if you know the actual Unicode, code point, you can definitely do 20B9 in here, and here is the rupee. This is how you can actually encode. So even emojis are allowed. Okay. So, but you need to know the Unicode, code value for it. So let's say might have somewhere given. Okay. So let's say laughing emoji. Okay. So Unicode. So there are some solutions also given how you can type this. Okay, you just put Alt and then type the Unicode value. Okay. So Alt 128514. So let me just try this out. Okay, I haven't tried it. I used it in Windows. Microsoft Word. Okay. So Alt 128514. So let's try this out. Alt 128514 and then release the Alt key. There you go. Right? And then I can just run this. So using the Alt key, you can do that. Okay. The emoji symbol is coming up. So a lot of variations are available. So using the Alt key, give the Unicode for any character in the entire character set, and you can see that value, and you can see that character, because your keyboard is not having it other than English. So even if you want to type Hindi, okay, you could do that, but then it is a big hassle. Truly, it's a big hassle. It's not that easy to actually type it using each and every keys, what to say, each and every letters character. I mean, characters from each and every letters Unicode. So that definitely will not be easy. Fortunately, because the strings, okay, when you are doing something like this, okay. Doing something like this, what happens is you can actually copy this code. So this namaste can be copied, okay. When you do a copy paste, it will work just fine. Okay. So you could do that. So, or you can give a binary value. So there are a lot of options in there because it's being a low level thing. Okay. So let's just see everyone. Okay. The Cyrillic version is also given. Okay. Yeah. So they always say, see, strings are not so simple because of this whole beauty of thing and so on and so forth. So you have to be a little careful while using this thing. Okay. So let me just show you where is that code. Oh, this is better. So this is what it is. Bytes and scalar values. So these are called a grapheme cluster. They call this as grapheme cluster. So basically, your string is 18 bytes, and this is how the computer is ultimately stored. So na, ma, and then sa, and then these are called as grapheme. Okay. Now English and Latin-based languages, they don't have this concept of grapheme. Okay. So graphemes is like you have a character and then you change over the character's vocal pronunciation by application of the grapheme. Okay, we call this as swar, adding swara, and while writing, we say adding matra in Hindi, or in Telugu you would say adding vattulu, right? The vattulu will actually change the pronunciation of the same consonant. Right. For instance, based on the graphing, you will pronounce ka as ka, or you will say ka, or ku, ke, cow, like that. Okay. So the base letter remains the same ka, and the grapheme is how you're going to pronounce it. Okay. So that pronunciation is added through matra or vattulu in Telugu. Okay. And that defines how exactly you're going to pronounce it. Right. So actually, it may look as if this whole letter namaste 1, 2, 3, 4. It's only 3 or 4 letters. No, it's not like that. Okay, it's not like that. Okay. Hold on a sec, please. Okay, so now if you look at it, okay, so there are 6 character values. Okay, but this one, the 4th one and the 6th one, they are not letters. They call it diacritics that don't make sense on their own. Finally, we look at these grapheme clusters. So every character in most of the Asian languages, because these are not available in the Latin-based languages. Okay, that is English, okay, French, or Cyrillic languages. Okay, so the Arabian and the Asian languages, they all use most of the languages. They use what is called as a grapheme cluster. So they are grapheme clusters. There's a base letter, and then added to it is a diacritic. They call it as diacritic just to make sense. But diacritics themselves have no meaning. You have to apply them. So the matras or the vattulu that you have, okay, simply writing them alone has no meaning. You have to attach them to a character in order to make it meaningful. Okay, so actual 4 letters are like this. Okay, now because this is so 4 letters, so that's 18 bytes. Okay, so if you look at the word Namaste written in Devanagari script, it is stored as factor of U8 value, and it looks like this. That's 18 bytes. Okay, so you cannot directly, what to say? Let me see. I think some. Yeah. So we had this Namaste in here, right? So let's say I just copy this, okay, and then okay, like this. So if you try to print, okay, right? Or even if you try to do something like this, let S is sign, okay, and then you try to take address of hello from say 0 to say 4. Okay. Okay. 0 to 4. So you see you are getting it. Okay, so that is it. And let's print it out. Print line. S is okay. So let's run this. Now you see it will panic. Byte index 4 is not a character boundary. It is inside this letter M. Okay. So you cannot do an indexing, okay, into this string just like that, because every character is a variable length character. So you might go to an index which is actually not exactly a character, but somewhere in the middle of the character. Because the first character, again, remember what you see as a character is actually a grapheme cluster. So it may span, one letter can span 1 byte, the next letter can span 2 bytes, the third one can span 4 bytes, the next one can span 3 bytes, and so on and so forth. Every character that you see in the output is having its own length. Okay, so you cannot do an indexing. When you do that indexing, there's a possibility that you might end up with, okay, with an index that is somewhere in the middle of the character, which doesn't make sense. This is the problem there. Okay, so what can we do? So what we can do is that sometimes when you want to play with the string, okay, so you do it something like this. Okay, so let's say for x in hello dot as bytes, you can do as bytes. Okay, right, and here you can do and then look at the individual bytes. Okay, X. And now and now let's run this. Okay, these are the individual bytes. Okay, let me just put it on one single line. So line. I'll just put a opening square bracket, not print line but print. I don't want print, and this also print, and at the end and here and now run this. Okay, these are the individual bytes. Okay, so let's do one. Instead of as byte, watch out. This will give you individual character. Okay, and now if I run this, okay, you're getting all these reference clusters. Now, and then there is a Halan, and then right, and then marker. So when you do charge, you will get individual characters. Okay, so basically including the diacritic. Right, now you see. And instead of using hello.charge, one more. 5, 4, and then one more option. Let me just label character values. We have seen that. Methods for using stars and then 5. Okay, the other 2 methods. So this will get to the individual character. So can we do? There's one more option available. We are still here. And let me show you. Iterating to Sure. Oh, there's a lot of options to look for. Okay, so basically, I could do that. I haven't used it. The reason being, I never required it. In most of the cases, I don't do. So let's go and hello. Okay, so I have to use this Unicode segmentation test. So then I have to. Okay, anyway, so external iterator for things. Okay. So you have to add them as external dependency. We will do that later on. Okay. So for now, let's continue. So Deepak, you can share a screen and continue that. Deepak?
Yeah. Let me check. My screen is visible, right?
Yeah. Yeah.
Okay, so this question you have mostly done the correct option. Yeah, let me go to the 18th one. Yeah, this one. What is the use of dot clone? Yeah, some of you need, most of you choose the first one. It has ability to duplicate object explicitly, but the correct answer, it works as deep copy, like Silva sir today also explained this concept. So the correct answer of this is both A and B. Okay, it is not work as shallow copy, it works as deep copy.
In fact, the truth is, please understand, both the first and the second statement are equivalent to each other. So when you say ability to duplicate objects, it means a deep copy. Kind of.
Yep. And the next one is, you have,
What is clone?
what is clone? Like 50% student mark the trait. Yeah, the trait one is the big, like, let me show you.
Clone with a capital C.
This is trait, and this one is a function.
Method.
Because how we use this one is, like, we use this type, and where we see the bracket, we simply say that it is a function. Okay, so next is, what is the role of underscore in the below code? Match coin, we are matching the coin. If there is something in the work, it works as, yeah, we have seen this underscore, that if we haven't find the proper condition above, then this is just work as a else statement. If we haven't faced any condition till now, then this condition will be executed. Okay.
So basically, this is like a default case of your switch statement in C, C++ and all. So basically, what that default means, if none of the matches, or none of the conditions have been met, then you do this. So it's like an else statement.
Any question, guys, you want us to address? Most of the tricky questions we have addressed. If anyone you want any specific question, you can ask.
Guys, now is the time for you to ask questions.
Yeah, no one is asking. Sir, we can begin our session. Silva sir.
Yeah. Okay. So let me just. All right.
Yeah,
So
we have a question, sir. If you
yeah, yeah.
can.
Sure. That's the question there. Difference between trait and function. A trait is a collection of functions to be defined later. Okay. Is it not mandatory for default statement in match? Abdul, it is mandatory. It's not really mandatory. Say for instance, if I'm using, let me just show you there. If I'm using on a, so suppose if I'm using it on a Boolean type, okay. So let B is assigned say true, okay. And I'm watching and I'm doing a match in here, match B, and herein I give true, and I return true and false.
Sir, your screen is not visible.
Oh, I'm sorry. I think I forgot to. Is it visible now?
Yeah.
So you see, a Boolean variable has only two, okay, options. Either it can be a true or it can be false. If you happen to cover all the options in there, then you need not worry about it. Okay. So that underscore default is not needed. See, underscore default means that you have some situations which you have not covered. Then in that case, you will need to put a default, underscore there. Let me give an example. So let's say I have, I'll just create an enum. Okay. Let's call it as by the name. What do I call? Okay. State. Okay. Wherein I want to give, let's say, values TS for Telangana, okay, TN for Tamil Nadu, and A for Karnataka, DL for Delhi, UP for Uttar Pradesh, okay. Oh, I'm sorry, enum definition. Now I have some Indian states, okay, and I want to work with, let's say, and I give it a value, let's say, state, and let's say I give it a value of Telangana state. Okay. And here I want to do a match on the Indian state. But I want to cover only few of these. So I'll say if it is yes, Telangana, TN, repeat, or say, and I want to create a variable of southern state. Okay, so let southern state, southern state. Okay, and for KA, I select Karnataka. And for other states, I don't, because those are not, say, Delhi, UP, MP, they are not southern states. So what I do is, for all those cases, I want to say, I want to return a string which is not a southern state. Okay. So the output of one of these will get stored in the southern state. Okay. Now I can just print line and say southern state southern state. Okay. So now let's run this code and see. Oh, I'm sorry. Okay. So southern state, Telangana. Okay. But if I change, know why this is coming, because again, you have to use allowed date code, so I can do that. Setting up. So this is gone. Okay. And yes, to match a variant, so it is asking you to put the state also, the variant temp. The reason why it is doing is now it is able to resolve, but right now, but it doesn't like it. The reason being TS, TNK might be used somewhere else in different contexts as well. So let's do that so that so I'm just showing you the strictness of the. I'll just take here. Okay, I see all the warnings are gone. Okay, so Telangana is coming up. Now, suppose what I do here is that I take the Indian state CS, instead of that, I say I'll take UP. Okay, and now when I run this, I get not a southern state. So what is happening? So out of this enum, you have covered only 4 variants. Whereas how many are we having? We have covered 3 variants. Okay, TS, TN, and KA. Whereas it has got 6 variants. So when you want to avoid all other variants inside of the enum, so again remember, if you put a match on an enum, then every variant must be covered. Every variant needs to be covered. So if you are covering only some of these and rest of them are not, this can lead to buggy code. So this underscore or the default, then it becomes mandatory. Okay. It is not, so it is mandatory in a sense that when you have match cases which don't have, which are not covering any of the values, there's some values will be left out, then in that case you put it. But in case if you have covered every value, like for a Boolean, you can only have 2 values, true and false. But if you're doing a match of true and false, you don't need to put this. Okay. So this is actually not mandatory. It's always optional, but under this rule that you can only avoid it if you have covered all the possible, values. Okay. So Abdul, I hope it, what to say, it answers your question. Any other question, please? Any other questions? So I think we don't have any more questions. So, okay. And today what we will do is we'll talk of closures. Okay. Basically, they are represented by traits, but you know, really need not worry. Okay. And yeah, closure. So what are they? Okay. So these are anonymous functions that capture their environment. That's the simplest definition you can actually see. But the question is, what exactly are these? Okay. What exactly? So these are basically, first off, you need to understand these are anonymous functions. That means these are functions which don't have a, not to say, a name associated with that. So how do you create a closure? So let's do that. Okay. So if I'm creating a function, right? If you create a function, can we continue in the next question? Not significant. So Deepak Chowdhury, can you address this question, please?
So me or Deepak Singh?
Deepak Chowdhury or Deepak Singh. Deepak Singh, can you just address this?
Yes, sir. We can address this. You can continue.
No, I mean, we have to continue, right? Because our session is till 9.
Yes, I hope. Let me confirm this
Yeah,
one.
just confirm it, please. While it's getting confirmed, we'll just continue our discussion. Okay. So first off, see, I can create a function inside a function also, right? So let's say I have, let's define test. Let's say front end. The test function, and then I can call this. So I defined a function inside the main function. So this is not at the global scope. So what will happen? This function test can only be called inside the main function only. right? So let's run this and see. Okay, we are getting it. A function within a function. Okay. And now if I have some variable, say let n is assigned 55, something like that. There's a test function. Value of n, and we are okay. Now you see this. Can't capture dynamic environment in a function item. So even though it function test is sitting inside the function main, it still cannot access anything inside of the main. So this is a very important concept. Please do understand what is happening here. You cannot access variables outside the scope of a function, and this is a rule no matter where you are. Okay, when you define a function within a function, the inner function does not have access to the outer scope. So suppose if I happen to define some variable before main, let global var is signed 1, 2, 3, 4. Okay. The error expected. Yes. Expect this, expect the semicolon after the rest analyzer. Expected an item. Okay. Let x be signed 5, something like this. You still get an error. Okay. What is the error? Expected this, and what is the value? If I expected an item. So you can't create variables in the global scope. But if I do it like this, okay, constant value is 99. Says it's not being used. Missing type. Yeah, constant, we have to give a type, right? So it is I. Wait. That's fine. Now you can use it. Okay. So you cannot create variables outside the scope of the function. So inside the function, I created the and but if I create a function like this, I cannot access it. So this is a big difference between an inner function and inner scope through the. So we can continue till 9. Okay, right. So how do you create an anonymous function, which is some languages call them as lambda functions, but lambdas tend to be a little different. Okay. So there are multiple, so we just call them in generic as closures. So closures are defined by using the pipe symbol. Okay. So the pipe symbol, you define it like. And then just write some code. Okay. And then I write some code. And I say, okay, so this is so you don't give a name. It's an anonymous. Anonymous means something that doesn't have a name. Okay. So in here, what I'll do is I'll say print line This is the closure, and line. Value of n is n and okay, that's it. So this is an anonymous function, but then this code will not work, have any effect at all. The reason being, basically what you have defined, what you have done is you have defined a function. Okay. You just defined a closure, unused closure. Must be used. Closures are lazy and do nothing unless called. So the question is, how do I call? So since this is a closure, see, can you place a call to the definition? So let's see. Call expression requires a function. Expected function found this. Okay. If you mean to create this closure and immediately call it, surround the closure with a parenthesis. So suppose we want to create this closure and we want to execute it as well. Okay. Just put it inside this and allow unused. Okay. So unused closure, that means closure lazy and do nothing unless called. And let's say I have this, and I put a call to this, and just there. So take this entire closure, put it inside parenthesis, and then put function call to it. Then you will be able to run it. So this is the closure, value of n is 55, and then you get the test function. So because you are calling the test function, right? So we have called this, but this is not the way generally it is used. If you were to create a closure and then run it here itself, then you might as well put the code straight away here. There's no point in doing that. So how we make use of this closure is like this. Okay. It's like this. So basically, we don't call it immediately, and then we call it only when needed. So what we do is we say, okay, let my closure is fine, and then you define a closure. Okay, and you see what its type. Its type is a function. Okay, and now you can call this. So I say my closure, and remember one important thing. Okay, what is happening here? When you say let closure is closure, and then you assign this, okay, then what exactly happens? What happens is it actually creates this function, anonymous function, and then stores that function against this variable. Because there's a common confusion when using closures. Okay, it is that when you put this, if the closure can actually take in arguments and it can return values as well. Okay, in which case sometimes people tend to think that whatever is being returned, it will execute and return a value, and that's what is going to be the code. No, that is not the case. Okay, so in fact, this when the compiler sees this, okay, it doesn't actually create the closure until and unless you use it. This is called as lazy initialization. lazy instantiation. So when the compiler sees that this is where you are actually calling, okay, the closure, it will get created and then it will be used. This is again an optimization to save upon memory and runtime, CPU cycle. So let's run this and see. So this is the closure, the value of n is 55. But importantly, what I want to show you here is that when you have a closure, it can actually access, okay, the surrounding environment. So right now, what it means is basically the closure is sitting inside the main function scope, right? So the closure has the ability to access the outside, outer scope, entities that are defined in there, which you can't do with a function when it is defined in an inner scope. It does not have anything access to anything in the outer scope. Closures have, functions don't. Okay, this is the major difference. Now closures are quite useful because basically closures are small snippets of code which, when you want, they get instantiated, run, and then destroyed. Finished, matter and clear. Okay, so this is primarily meant to bring in efficiency. So also, suppose if you're going to create or you want to run a piece of code only once or only for a specific time, and then you don't want that code in the rest of the program, you can create a closure for that. Okay. Now closures can take arguments. So okay, closures with parameters and return value. Just like function. Okay. So suppose if you want to return a value, right? So let's create let closure with a return value, and it's a closure, and it returns a value. Let's say it returns a value of type U8 or U32. Okay. And we just return some value, say 1, 2, 3, 4, 5, 6. So it is returning. We haven't used it, right? So line calling closure with return value. Then call the close. So it should print okay. It should print 1, 2, 3, 4, 5, 6. Right? So let's see. Okay. Right. So the closure can actually return a value. It can also take in parameters. Okay. And it can have a combination taking parameters, returning values, and so on. Okay. So let's say we define let closure with param and return value. I'll just create a closure which does addition of two integers. So syntax is exactly the same. The only difference is there is like functions, but the only difference is from a definition standpoint, no name needs to be given. And instead of function name followed by parentheses, instead of parentheses, we use the vertical bar. So I have, let's say, first, and it is again, you have to give the type annotation. So U32, second is a U32, and it returns a U32, and let's say this, we'll call this as okay, we'll call it as closure add. Okay, and what it will do, so let's just create, deliberately I'm writing some additional code which is actually redundant, really not needed. Let sum is assigned first plus second, and what we do is we return the sum. Okay. Using the tail expression. So what is happening is that the closure add is adding two values, so whatever is passed, and then it returns the sum. Okay, so now I can use this, so I can say print line sum of this and this using closure is, so sum of, let's say, 10 and 15 is, so what we do, we call the closure using the closure add and pass in the 10 and 15 there. Okay, so yes, oh sorry, right. So sum of 10 and 15 using the closure is 25. Okay, there is another big usage of closures, and that is closures can allow you to do functional programming. Okay, so I think there is some question there. Okay, that means you can create functions which can be passed to other functions as arguments, right? Usually we only pass values. Okay, so how to go about this? So I will show you functional programming power of the closure. Okay, functional programming using closure. Now, functional programming, okay, what does it mean? Means that functions are treated as first class. So that means functions themselves are objects. So what is the implication? The implication is therefore they can be, or you can say functions can be passed to other functions as arguments. Okay. in Rust, this can be done using closure. There is something that you have to keep in mind. Okay. So let me define a closure. So I'm going to create two closures. Okay. Let's call it. So let me just do this thing here. Okay, I'll take a simple example. So I have a closure, and we need to see what is the type of the closure also. Okay, so if you see the closure with return value, again, it's a closure. Okay, it's a closure which returns a U32. Here, close and is a closure that returns a U32. Okay. So let's define I define a closure called add. Okay. A of type U32 and B is of type U32. Okay. And it returns a U32. And I don't want, I just want to write a single line of code, and that is A plus B. Okay. Next. So when you have single line of code, you can actually avoid, so there is, and there is no return type. Okay. So we can do that. I'm sorry. But since there is only one line of code, I think I can. Yeah, okay. And we define another closure, subtract. Again, A is of type U32 and B is of type U32. And it turns a U32. Okay. A minus. Okay, so I got two closures. Right? Okay. So now I write a function. Okay. Let's say I can take a this one also. Okay, say okay, let's compute is assigned another closure. Okay. That's a operation. Now the question is how to say that this is actually, a closure that I am going to pass in. Okay. So for that, I can say, hey, what I'm passing is an actually a function. Okay. And then A is of type U32. B is of type U32. and it returns a U32. And what I do is I return whatever the operation returns. Operation, because it's a function, I can pass in A and B. And whatever it returns, that becomes the return value. Okay. So now the question is, you're getting in here of function version to the call operator that takes in an immutable receiver. Instruction can be called repeatedly without mutating the state. If state so it also says, see the chapter on closure, chapter 13. So let's copy this. Okay. So capturing references or moving ownership. So this you can read upon it. Moving captured values out of the scope. Captured by the continuous closure. Okay. Okay. So let's come back up here. Fn is as a use Fn as a bound. Okay, why? To accept parameter of function like type and need to call it repeatedly without mutating state. So anyway, we are not doing that. Okay. So now let's call this. So I say, okay. So if I say line. Okay, let's define two variables in here. That n1 is 10 and let n2 is 20. Okay, so let's test it out. Add years and then add and then pass in n1 and n2. Okay. Right. Now we are still getting okay, so I'll just give it a So call expression requires okay, expected function found. So you can say that this is a function that is type F. A trait is similar name with the FN example. So let's see. Function is argument. Yeah. In the Rust book itself. So you can have function pointers. So add one, do twice. Okay. So, oh, okay, okay. So instead, I need to define the actually. So my operation is of type. So I have to define the exact type. So this is a function which takes in U32 and the U32 and returns a U32. I think this should come up. Yeah. And this variable compute. Okay, that's fine. Code and allow okay. So when I call add directly, okay. So I'm add gives 30, right? So this is working. But instead of this, what I can do is, okay, you can actually see any operation that is a function, it takes into U32 and returns the U32. So add and subtract, both of them fall into that category. So I can actually selectively call this, okay. So based on my choice, right? So let's see. So I can say print line. Okay. So function program. That means I'm passing operations to other one function into other function. Okay. So line passing add into compute. Okay. And then I say print line. So using add with compute. The result is, so I should get 10 plus 20 is 30, right? So Now the question is, how do I call this? So to call it, I will say compute, and then inside the compute, pass in the add as our function. I say, and then n1 and n2. See that? And then again, I use the same kind of code. Okay. But this time passing subtract. So subtract. Okay. So you can see. So inside this, so I'm using compute to do both addition and subtraction. Okay. So now if I run this, oh, I'm sorry, not U32, I32. So let's do it like 50 and 20. Okay. So that, because it's unsigned, right? So that's the reason. Subtract is the issue. Okay. So you see, using subtract in compute gives 30, and using add in compute gives 70. So it's working just like. Now the question is, what is happening here with these compute? Okay, close. You are able to now pass in, okay, function within function. This is absolutely great, because now this gives you additional level of control over your code and how you can do that. So this is function program. Okay, let's look at this. First class object. Okay, Shivkumar, first class object means a function is also treated as an object, so that it can be assigned to a variable. So a function as such cannot be assigned, but what we are doing, closure, I can assign it to a variable. That's what I'm doing, right? So the closure can be assigned to a variable just like this. So I say this is the closure there, and we are assigning to the variable called compute, because using this, let's add, subtract, these are all variables, but they act as, because what you are assigning to is actually a closure. So obviously this will be used like a function. Okay. Okay. Right, guys. So that's it from my side. Okay. So you will have this code with you. Okay. Shortly, Deepak will put it in the GitHub and send you the link. Okay. So Deepak Singh, are you there?
Yes, sir. So
Okay.
I guess now, so a lot of
Today we
people
can't have,
already are.
yeah. So we
Yeah,
can't
yeah.
have the quiz today. Okay. And because of the explanation of the previous code, so today's session, all the topics need to be covered before we can go in. So I think probably you can discuss it with Praveen sir. We can have one competitive session, okay, where you can get up to speed and then come back on track.
No worries.
But
So guys, just to update you that we won't be having a quiz today, because before we do the quiz, there are certain topics that need to be covered. So before we can't have a quiz without that. So a sigh of relief for a lot of you who have been asking for the link. So yeah, any closing comments from Selva sir, from you, and Deepak from you?
yeah, that's it. So you have seen the discussion today. Okay, we'll get this code also. But again, remember, as we go on further and further, because we are very close to starting substrate. So remember, you have to gain experience of working with Rust, and so it is important that you go through the Rust Clang book, and if possible, some amount of Rust by example book as well. Okay, please read through, do your research, and so that you are up to date with at least intermediate level of Rust, so that the upcoming sessions on substrate will not seem very daunting to you, because that's a full-fledged framework which has been which uses all the advanced features that Rust provides. So you should be at least comfortable enough that even if you don't follow some of the feature that is being used, you can do you can look it up on the internet and look through the documentation. That is the kind of R&D that you have to do. So so please be aware of that fact, so that you are comfortable enough to handle all that. Okay, guys. Deepak Chaudhary, any inputs from your side, please?
No, sir, you have mentioned all the points. That's it.
Okay. Okay, guys. So I'll see you in the next session. Okay. All the best, and please keep up your studies because now you are going to do substrate very soon. So it will be imperative that it goes without saying that you must have done your background work in order to feel comfortable to use that. Okay. So see you guys in the next session. Bye bye.
Thank you everyone for joining in. Next session will be on 15th. So make sure you mark your calendars. Same time, 7 p.m. at the same link. Thank you guys once again. Thanks for joining. We'll catch with all of you soon.
Okay. Bye bye.
Thank you, Silva sir. Thank you, Deepak.